All right, scholars, thanks for tuning in again. We're going to take a look at soil degradation. This presentation will help you understand soil erosion and degradation and soil conservation principles. So first of all, erosion and deposition. We think of these as, at least erosion, as a bad thing. We can define it as the removal of material from one place and its transport elsewhere by wind or water. But actually, there's some real ecological importance to this. Because when you have erosion from one area, it can bring with it nutrient-rich soil to another area. And when that soil is deposited, we call it deposition, the arrival of eroded material at a new location. So here we see a river, has a wide and deep channel. And every once in a while, maybe every few decades, perhaps once a century, this river is going to flood due to intense rains. And when it floods, it overextends its banks and will leave behind deposit along what we call the floodplain, which is next to the river. And that deposit is usually nutrient-rich soil. So this can be a really good thing. These processes are natural and can build up fertile soil, such as on the floodplains of rivers. If you think about where some of the origins of agriculture are, they're in typically floodplain areas like the Euphrates River in the area we call Mesopotamia is well known as one of the earliest civilizations due to its use of agriculture. Okay, so by erosion, the other side of it is too much erosion is a problem for agriculture. It is commonly caused by over-cultivating, meaning too much plowing or poor planning. By plowing, we mean taking dirt, topsoil, and flipping it over basically. So you put weeds underneath the ground to make them die. And overgrazing rangeland with livestock, they're eating up too much vegetation. And deforestation, especially on slopes. And in all these areas, we're basically removing vegetation. And that vegetation is important for giving structure to the soil. The roots can help hold the soil in place. Here are some types of soil erosion. This is FYI. There's different kinds we'll discuss here quickly. Splash erosion, you can see a drop here, rain, causing dirt to go away, soil to go away. Rill erosion, gully erosion, and sheet erosion. What you should know about all these is that they're more likely to happen when slopes are steeper, because now gravity can more easily help remove the soil. Another little FYI here, measuring soil erosion. They have some pretty cool things here. It's called an erosion pin. You stick it in until the top is flush with the soil level, and then you come back later and you see how much of it's exposed. And then you have this depth gauge, which can help you actually measure how much is left. Soil erosion is a global problem, and it's coupled with rapid population growth. These two forces spell crisis for the future of agriculture. Basically, we're trying to get more and more out of our land, more and more yield, yet because we have more and more people, but that's overtaxing the land, and at the same time, we are having a loss of that topsoil. Humans are the primary cause of erosion, and humans are over 10 times more influential at moving soil than are all other natural processes combined. And a little fact here, in the US, 1 inch of topsoil is lost every 15 to 30 years. And this topsoil can take an extremely long time to build up. So how much of a problem is this really? Well, from 1957 to 1990, China lost as much arable or farmable land as exists in Denmark, France, Germany, and the Netherlands combined. And in Africa, in the next 40 years, soil degradation could reduce crop yields by half of what they are right now. And think about how Africa is one of the fastest growing countries in population size. So we have some challenges ahead of us. Let's take a look at some ways in which soil can be degraded. One is called desertification. And it's a loss of more than 10% productivity of the land due to erosion. By productivity, we mean how well it can grow food. Soil compaction, where it's just getting too hard, it's getting too pressed together. Forest removal through logging activities. Overgrazing, and so here you see a large number of livestock. It takes a lot of vegetation to support this many goats. And if you look around, there's not a whole lot of vegetation there. So this is the case of desertification. They pretty much have eaten up or over-eaten the vegetation. Drought can also lead to desertification. Salinization of soil, which means there's too much salty minerals that are on the soil. And climate change. And also depletion of water resources, etc. So this can all happen. It can all affect the quality of the soil. So on dry lands, most of soil degradation is caused by two things: wind erosion and water erosion. There's also to some degree, there's chemical problems where the soil gets contaminated with chemicals, and there could be soil structure problems, things like compaction of the soil. Major event happened in the 30s, the Dust Bowl. It was caused by drought coupled with degraded farmland. And as you can see here, you have dust that blew. So this here showing storms brought dust from the U.S. Great Plains all the way to New York and Washington and wrecked many lives. It was intense. So you had a couple of decades of intensive industrial agriculture happening. And that really, some examples of that would be plowing the fields, taking big tractors, running it through the field, and it really disturbed the structure of the topsoil. And so it lost its ability to hold together. Then you had a big drought come, and so that soil dried up. And then you had big winds come, and that dust from the soil that was dried up was blown, in some cases, all the way to New York and Washington. And we can even see here just how thick the dust is. You can see these posts, you can see this door. This used to be a full-size door until the dust came and filled up to the midpoint. So what happened? What did we do as a response? This is a little FYI, but there was some legislation passed, the U.S. Soil Conservation Act of 1935, and Soil Conservation Services, which was a government service to help conserve soil. And these services are, in this case, it was mostly local agents in conservation districts who worked with farmers to disseminate scientific knowledge and help them conserve their soil. Here's an example of modern soil conservation. Many nations follow the U.S. lead on this, and so today you have local conservation agents helping farmers in many places in the world. And Brazil's no-till effort is based on local associations. So in this picture here, we see a farmer in blue and an extension agent in Colombia. Extensions are parts of universities that interact with local business and local, in this case, farmers, to try to disseminate knowledge that are gaining from research studies at the university. So how do we prevent soil degradation? There are many strategies. We can do crop rotation, contour farming, intercropping, terracing, shelter belts, and conservation tillage. We're going to take a look at each one of these. Crop rotation means alternating the crop planted, e.g., example, between corn and soybeans. So one season you might grow corn, the next season you might grow soybeans to help restore nitrogen into the soil. And this can restore nutrients and help fight pests and disease. Because you might have a pest that really likes corn during the one season, but then the next season you're planting soybeans and that pest goes away or dies, rather than sticking around for the next crop, the next year. Cover crops can be grown in between the large collards in this. Well, cover crops can be grown alongside crops or during the off season. And so here you see large collards, and there is a cover crop mix of rye and crimson clover, and that's what you see in between the rows. Rye is like a type of grass, and they're protecting the soil from harsh winds and eroding, compacting rains. Here we see contour farming, planting along contour lines of slopes helps reduce erosion on hillsides. So you might remember from elementary school learning about contour maps and how to read them. So the idea here is that all these different terraces or levels, well, actually these aren't really terraces, but all these lines that you see here are basically at the same level, so that you don't have erosion going downhill. So let me just give you an example. The top of this little hillside here, right here, water that hits here is going to want to flow down. But because of the way that we have these rows laid, the water is going to hit here and it's going to get slowed down. And it might even just then slow down to a point where it's able to infiltrate back into the soil, which is a good thing. So contrast this to if you planted all these rows going downhill, then you would have basically the opposite effect. Any water that lands at the top is going to run right down the rows, gaining speed as it does, causing more erosion. So this can help reduce erosion on hillsides just by putting your rows along the hillside rather than down the hillside. Intercropping is another way. You can mix crops, such as, in this case, what's called strip cropping, which provides nutrients and reduces erosion. It can also reduce pests and disease. So if you look here, each strip is a different crop. And for the same reason as we just saw, it can reduce erosion because these plants that are lower can help slow down the flow of water, whereas if you just had a whole row or a whole field of corn plants, they're not as good at slowing down the flow of the water. And also reduce pests. Because you might have one kind of pest that likes this corn, but you might have, because it's a smaller field, its population size might be smaller, so it's not going to spread as easily. You might have another pest over here that also likes what's being grown, but maybe it can also feed on the pests that are in the corn. So you have greater biodiversity, and with that comes more predation, which can help control the number of pests and disease as well. So you think with disease aspects, sometimes plants get a kind of fungus growing on them, for example, and because this row, perhaps it would fall prey to a fungus, but because there's enough distance between it and the other corn row over here, the fungal spores might not be able to transfer over as easily. So it can help reduce the spread of disease. Similar to how we talk about in cities where the population density is greater, for humans, there's greater transfer of disease. All right, terracing. This is cutting steps or terraces. It's the only way to farm extremely steep hillsides without causing massive erosion. It's labor intensive to create. I mean, that's a lot of digging with a shovel, but has been a mainstay for centuries in the Himalayas and the Andes. And so here we see how, everything is in steps. So the water doesn't really flow down so easily because when it hits a flat spot, it pretty much stays and sinks into the ground or soaks in. Shelter belts can reduce wind erosion. These are rows of fast-growing trees around crop plantings, which provide windbreaks, reducing erosion by wind. So wind's coming along, hits these trees, and these trees slow down the wind so that it doesn't cause as much erosion between the trees. Conservation tillage is where you do no-till or reduced tillage farming, which leaves old crop residue on the ground instead of plowing it into the soil. And so this covers the soil, keeping it in place. And here corn can grow up out of a cover crop. So basically, rather than tilling the land, which would be taking all this stuff you see on top and using a tiller attached to a tractor, which basically flips over the top of the soil so that all this stuff you see here would get buried. Rather than doing that, we let it sit on top. And since it's sitting now on the top, it's covering the soil, which is helping to keep it in place. And this is actually now used in half of U.S. agriculture, whereas in that Dust Bowl era, we pretty much did tilling. So some details about conservation tillage. It can provide increased crop yields, less erosion, and healthier soils at lower cost because you don't have to go through the process of tilling, and that takes fossil fuels to run your tractor and everything. However, it's not a panacea for all crops everywhere because it often requires more chemical herbicides because weeds are not plowed under. That's one reason we plow, we get to bury the weeds and kill them. Now you need to use chemical herbicides to help control them. And it often requires more fertilizer because other plants are competing with crops for the nutrients, and some of those weeds, for example. But legume cover crops can keep weeds at bay while nourishing soil, and green manures can be used as organic fertilizers. So there are ways of controlling for these two things in using organic methods. We say organic agriculture methods. This has been big in Brazil, and so some of the benefits of this: it conserves biodiversity in the soil and in terrestrial and aquatic ecosystems. It produces sustainable high crop yields. It heightens environmental awareness among farmers. Provides shelter and winter food for animals, reduces irrigation demands by 10 to 20%, and the crop residues act as a sink for carbon. So you actually have, rather than CO2 being in the air acting as a greenhouse gas, you have that carbon stored in the crop as biomass. And it reduces fossil fuel use by 40 to 70%, enhances food security by increasing drought resistance, and reduces erosion by 90%. That's a big number. So all these techniques in combination can give really big results. And there was an example in our textbook about the Guatemalan highlands farm that increased their yield from 1 ton per acre to 11 tons of food per acre between 72 to 1994. Some other benefits arising from the reduction in erosion are you get reduced silt deposition in reservoirs. With erosion, it's got to go somewhere. Most rivers, often rivers, end up in a reservoir because there's a dam there. And so now you have silt that's building up at the bottom of that reservoir. It can reduce water pollution from the chemicals that you applied to your farm field. It can increase groundwater recharge because now the water is not flowing as fast, so it can recharge back. It can infiltrate into the ground and recharge your groundwater. And also lessening flooding, which happens when the water doesn't infiltrate but keeps flowing on the surface. It can increase sustained crop yields and lowers food prices. With better yield, you get lower food prices. It can lower the cost of treating drinking water because there's less chemicals in it. It can reduce the cost of maintaining dirt roads. Dirt roads will erode away. And it eliminates dust storms in towns and cities, like we saw with the Dust Bowl. And it increases the efficiency and use of fertilizer and machinery, since the soil that we apply the fertilizer to isn't getting washed away. Okay, we're going to stop there, and in part 2 we're going to take a look at irrigation.